Good math. And let me adjust the camera. So we're going to go ahead and flip the camera over. There you go, guys. Today we're going to talk about polynomials. Talk a little bit about polynomials today. So you got it. Come on in, guys. Come on in. We'll wait till the room warm up. We're going to do this for 20 minutes. We're going to do all theory. We're going to do all theory. So I'm going to scoot this back a little bit. And we're trying to... All right. So, yeah. So we'll do theory of polynomials. So I'm going to try to leave some space for you guys to see what's going on. So it's going to be a cool class, guys. So we'll let the room warm up a little bit. So again, guys, just a brief introduction to polynomials. Nothing too spectacular. So come on in, guys. Adjust this camera. There we go. Okay, we got a clear board. We're clear board, so we're gonna wait. So as you guys coming in, we give a 5-minute warning. So those who are watching, guys, welcome to my YouTube channel. Thank you for coming in. I'm the math tutor. School has started. This is the 5th day back in school, I believe. And for colleges, they start on the 24th. And right now we're going on some algebraic concepts. We're going to talk a little bit about polynomials. We're going to do the zero property. We're going to do the foundation of polynomials, how they came about, how they arise. And we're going to show a specific example of the use of polynomials in the application, guys. This will be really cool. So welcome in, guys. So keep coming through, guys. Go ahead and like the screen for me, please. And we're gonna get started. All right, so here we go. So what is a polynomial? So we're gonna do polynomials of the form. So polynomials, right? This is of the form, so this is the definition. So you say you have a mxm all the way to a sub naught, and where a are real constants. A1 to an are real constants. Constants. Okay, this is the definition of a polynomial, guys. And x is the variable. This is what's changing, so x is continuous. So polynomials of the form of any degree can be expressed in any degree. Okay, it can be 1 degree, no matter what, any degree of that form. So we'll take our time with this. So make sure you keep liking the screen, guys. Like. Go ahead and comment. How you doing? Hello. What's up? How you doing? Let's keep engaging, guys. Let's engage. Tap the screen for me, please. Like the live. We're talking about polynomials. Main polynomials, it can be expressed in any number of terms, any number of degree. So we need that definition. So that right there going to be our precipice of our lecture for the day. I'm going to try to do these once or twice a week for you guys whenever I get the chance to do so. So don't forget to like the live, guys, when you look for subscribers. All right, so come on in and make sure it's real clean. All right, so let's go ahead and continue. So now we're going to do our first proof of the polynomial, guys. We're going to do a proof. All right, so we're going to allow our theorem. So what we're going to do, we're going to expand. So it'll be AM xm, we're going to add a term, right? M minus 1, m minus 1 plus, all right, am minus 2, xm minus 2, and we're going to do this till we get a sub naught. And then we'll set the whole thing equal to our a to the m, x to the m, which implies the fact, right, it's nice and neat, a to the m, x to the m implies a polynomial of any m degree respect to x. This is our first theorem, guys, by expansion and the definition of a polynomial. So this is our first theorem. Go ahead and like the live, guys. Go ahead and subscribe to me, please. Hello, how are you? What's going on? How are you guys? Hello, how are you? Welcome in, welcome in. Let's keep coming in, guys. Make sure you like the live. I want you guys to subscribe to me. All right, yeah, I'll leave this up. So this is actually polynomial, guys, of the form. All right. I know I got a little bit of accent. That's my show accent. I speak English. So remember, the polynomial is of the form of am to the x to m. All right. So this is going to be a little bit different lecture from my previous one. All right. So now we can express this as now in the theorem. So this is going to be our first theorem in this case. So let's say a polynomial is P or P of n respect to x, right? Can you express in any form such that, right, that P of x is equal to, right, let's put n, P of x, a to the n, x to the n, period. Which can be a set of, so this is a set of linear combinations. That's all it is, right? This is a set. So it is a set of linear combinations. So we just proved that fact. And where a are real constants, a1 to an are real constants. Okay, of course, it's or a are real constants. All right. So that's very important. Welcome in, welcome in. How you doing? Hello, everybody. Thanks for one engagement. Let's keep liking that live, please. Let's subscribe to me, please. Let's subscribe. Okay. Okay. I'm just messing with you guys. How I do it? You know, I don't know. It's just a habit. I'm sorry about that. You're not a second graders. Hello, everyone. Hello. Make sure I'm reading your comments. Hello. Hello. How are you? You great? Good. I'm well. I'm well. Let's keep liking that live, guys. Keep liking the live. Go ahead and subscribe to me. Let's be respectful, please. So this is our first theorem that we prove. P for any polynomial of the form P of x e to the a m to the x m power. All right. We're going to get a little bit more detail tomorrow. So yes, you need to get the operations on polynomials tomorrow, so the proof will be more intense. So the first theorem of the polynomial, and the second theorem. So our second theorem will be of zero, guys, called the zero property. So we're going to do P of n with respect to x is going to equal 0. All right, P of n x equals 0, guys. So, and we'll let n be any integer. N or the whole thing in the real numbers. So we only want real solutions, right? So we'll control it by using real solutions. So that's our first theorem, guys. It's called a zero factor theorem. Okay, we'll do more tomorrow too. So what we're going to do, guys, we're going to show you some demonstrations. This is a very important theorem, guys. This is very critical. So we had 12 minutes already, so we'll wait for some more people to come in. Come on in. We'll keep going whether you're in the room or not, okay? So we'll study the zero factor theorem. I'm also doing this video for a backup video of my last lecture, so I'm trying to be as explicit as I can. So we're going to prove the zero factor theorem right now. So let's P of nx equals 0. That's going to be our initial start. So P of x is going to allow us to have x minus some number a. Okay, x some number a times P of x. Okay. So now we will allow, okay, since x equals a, P of a then becomes P of a minus a, moreover 0 times P of a and thus P of a is a 0, right? Since x equals a. Hence, P of n of x minus a is indeed P of n of x equals P of n of some number a gives you 0, period. So that's our proof of the zero factor theorem. So that is our proof of the zero factor theorem, guys. Okay. And then we're gonna do this is a paragraph proof. We're gonna do a symbolic proof next. So let's be more explicit. Okay, so here we go. Here we go, guys. So we're gonna let x equals a. So P of A is going to equal P of A times A minus A. So 0 times P of A equals 0. So hence P of A is a 0. Okay? P of A is a 0. That's why we call it a zero factor theorem. We solve for those numbers. Remember, that's where and it's also important because it tells you where your graph intersects, right? Where your zeros are located. The zero factor theorem will help you locate the zeros in the polynomial by factoring, right? So it could have one or many real solutions to the equation. We don't know. So just on a little bit of auspice. So if we allow a polynomial of any type, it's going to approach a real number. So we'll call this some number n. So I have AMXN, a sub naught, it's going to give us some number n. So it's going to approach that number n. So the limit as x approach some number a, p of n respect to x equals p of n a, which gives you some number, right? So n element r. All right. So we know that polynomials converge or could diverge. So it could converge or diverge. Hold up, guys. All right. So we're not going to get too deep with polynomials. And again, this is a synopsis. So we developed an abstract idea of a polynomial. So let's experiment. So we're going to solve for this polynomial right here, ax minus b equals 0. We're going to solve for that. So this would be ax b minus plus b equals 0 plus b. Ax plus 0 equals b. And now we undo each operation. Equals b. And we're going to add the inverse a to a equals a b. We're going to do a 0x negative 1b, and therefore x equals a. So we say x equals a 1b is a solution. To that polynomial, right? Which is true. We have to go through all the properties to prove such proposition. Welcome in, welcome in. Okay. So what we just proved here, we proved that there exists a solution to this linear equation such that x equals a to the negative 1, or the opposite, the inverse of 1 over a times b. And we're going to have to check it and make sure it's valid only for that, right? So we solved for that. Now we're going to have to check it. Make sure everything checks out. And the objective is to get to 0. And we're going to put that as a theorem as well. This is a special case of that. So we showed you the general case, and I'm going to show you a specific case. So I'm going to say let x equals a1b, period. So a minus b. All right. Okay, b minus b. A to the 0, b minus b. Okay, put in imply. So we'll put a comma. So comma, 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 comma. So 1 times b minus b, comma, b minus b, comma, 0. So we wind up with 0. So thus that does checks, and it is true, a solution to the equation. So that'll be our 0. Welcome in, guys. Welcome in. So that'll be our 0, guys. Welcome to my YouTube channel, guys. We do this we can. So this is the idea why your solution works, right? Why we have a solution to this equation. It's what you learned in elementary school. Why do we multiply the way we do? Because of these theorems, these properties of real numbers. So that's important. So again, we're doing a detailed theory of equations, guys. So so far we did zero factor theorem. We did a special case of that. So we're gonna do another special case, and we're gonna look at it. And we have. So now we come with a definition, right? So this is gonna be another theorem. So we have Pn is a polynomial. To any nth degree. Okay? I'm representing a polynomial to any nth degree. So also in element z such that n is more than 2 in R, right? The whole thing in R. And we just proved that, right? And this is by definition. So to prove this, we need a definition of a polynomial, right? Period. So any nth degree polynomial, it can be 1 degree and all that. We're going to show a demonstration of that in a minute. That's why we came up with that idea of polynomial. First, we needed the definition to help us define what a polynomial is. And then we use other theorems that's related to that. Okay. If you guys are watching, you can watch this later on once we get it posted. So this also notes to me, so I can refer to them later. So it's a lot to polynomials. We're just doing the basic algebraic properties of that. So basically, sorry guys. So basically, we got to prove a very important property of. So basically, the proof goes like this. So we let P be any nth degree polynomial of x. And it's going to allow us to write this. Okay. A sub naught. All right. It's going to allow us to write that. And then we can expand this in such a way okay, we're going to expand it in such a way that P of m minus 1 is back to x minus some number a, which gives us x minus a1, xn minus a n. And those factors will give us x1 minus a1, an minus xn, all equal to what? 0. Or in general, let's make it a number. So let's make it 0. Yeah. So that gives us exactly what we want. Okay, that gives us exactly what we want right there. So we have proved such proposition. And this is going to lead us to other ideas in mathematics. So polynomials, get used to it. All right. So we're going to try to end this with one more proof, and we're going to get on out of here. So if you guys are taking algebra and want to learn about polynomials, refer to this video. All right, for more details, you guys a reference for more details. We're going to do pre-calculus. Pre-calculus by Michael Sullivan III. Right? And we'll do calculus by Stewart. Okay, those two references, I want you guys to look it up. Reference, yeah, those reference, yep. Look it up. Want to know more about polynomials? So by Stewart. Go ahead, guys. Go ahead, like the live, guys. Like the live. Let's go ahead and subscribe to my channel. That'll help me out a lot to push it out to further on the algorithm. Thank you. This might be a little bit longer video. We're trying to get the word out in mathematics. I do private lessons as well. Hit me up my DM in the comments. We can talk about it. All right. So we did a zero theorem. We did a more detailed proof of the zero theorem. We did the You start off from scratch on how we construct a polynomial by using linear combinations, okay? So basically, the polynomials are really a set of linear combinations, which is called a span, right? So how polynomials are formed? So they are formed by linear combinations, okay? So let's look at another theorem. Let me see. Will be another theorem. Hold on, guys. One more theorem I want to cover. The fundamental theorem of algebra. We can do that. Okay, I think we're done, guys. That's it. We're done. Okay, if I can't think of no more. So let's go ahead and summarize what we have done, right? Theorem. So we did number 1. We defined a polynomial of x, right? X, R. By definition, that's our proof. 2, we did what they call the zero factor theorem. So we did P of in respect to x equals P of n x minus a equals 0, right? So that'll be zero factor theorem equals 0. And 3, we say P of x, P of nx can be expressed as a n x to the n, right? So these are 3 main concepts, and one more I want to introduce you guys to. 4, we have a constant times P of x, okay, or k times P of n x, and so we want n be more than greater than 2, right? So that's what I have for you guys today. So make sure you take note of that. If you guys So yeah, guys, so we are done for the day, and we are truly blessed that you guys came on, and we'll see you later. Thanks for coming in. Bye-bye.